Alright, so this video is about the full installation of a NAND-AID into a Wii U. And I'm redoing this because the audio in my original video is garbage. So the first thing I'm doing here is using an X-Acto knife to cut the trace near R26 on the board. I recommend going slow so you don't accidentally slip and cut something you're not supposed to or knock something off the board. These components are small and they're delicate. Once you cut the trace, I recommend checking it with the multimeter. Set the multimeter to continuity mode and put each probe on the 2 points on either side of the trace you just cut. So the outside points, which are solder blobs. Why am I changing this? I shouldn't change this. I'm changing it. That's what you see me doing right here. I'm checking to make sure that there's no continuity between these 2 points. Now I'm bringing over the NAND-AID and I'm going to test fit it to make sure everything lines up. You need to make sure that all solder points are in line before you solder down the ground point. Now over here is the first ground pad that you want to solder the NAND-AID to. This solder point holds and grounds the NAND-AID in place. Without the ground pad, the NAND-AID will not work. You want to make sure you get good solder joint on this point before you move on. Alright, so I'm adding some flux here to get the solder that was already on the board flowing. A lot of this solder is extremely difficult to get flowing, so you will probably have to add both flux and new solder to get it to flow. And you'll see in this video, when I go to move this, the stuff really doesn't melt, and it's quite common on old solder joints, so just keep adding flux, keep adding new solder. Eventually it'll flow and you'll be able to get it off the board. Now what I like to do is remove the old solder on the board the best I can, and the reason for this is old solder on the board doesn't flow well and doesn't make good strong joints. So what will happen is you will think the NAND-AID is soldered in place and secure, and it's going to pop off the board once you get the SD card slot soldered in place. At that point, it's too late because in order to solder it to the ground point, the SD card slot must be removed from the NAND-AID. So do yourself a favor, don't end up in that predicament, and just remove the old solder and use fresh new solder to solder the NAND-AID on this ground point. So what I'm doing off camera here is I'm grabbing some solder wick. And solder wick just wicks the solder away by sucking it up. You can buy this on Amazon, and this is really the best way to remove this. So just be careful when you do this. If you pull really hard on this, you're going to rip the pad off the board and you'll probably damage something that's not repairable. The solder wick should pull away from the board with little force or effort. So if it's stuck to the board and you can't get it off, add a bunch of flux to the solder wick and the solder joint. If that doesn't work, add some fresh solder back to it and then add more flux and heat it up. It should just slip off very effortlessly. Otherwise, like I said, you're going to end up damaging the pad on the board, which is quite common. The other thing too is you don't want to hold this solder wick with your finger because it's copper and it's going to heat up on both ends. It's going to heat up rapidly. So grab a pair of pliers if you don't have those. Grab a pair of tweezers. Usually anybody who's working with this type of equipment is going to have one or the other. Alright, once you have the old solder removed, now what I'm going to do is come in here with some isopropyl alcohol and a Q-tip to clean this spot up. Now, that looks pretty good. So I can add some fresh solder to this pad and get it ready for the NAND-AID. And that's exactly what you should do as well. Again, if the solder's not flowing, add some flux like I'm doing here. And then I'm going to come in with my hot iron and just move this around. Alright, I said in my original video, and I'm going to say in this one, what I found is working with a microscope and a camera when trying to solder, because the area I'm working with is small, is very difficult. So what you're going to constantly see me doing here is shifting where the soldering iron is coming in from in the frame in order to heat up the solder. Also, the camera's going to move around a little bit here and there as well because I just can't get my hands in here with the microscope and the camera. Right here, you need to line up these gold contact points with the resistors on the Wii U motherboard. Once you have them lined up, you can use a piece of Kapton tape to hold them in place so you don't accidentally shift the NAND while you're soldering the ground point. And that's what you're going to see me do right here. Once you have the Kapton tape in place holding the NAND, then we're going to go over here and we're going to solder this ground point. And this ground point holds and grounds the NAND in place. Without this, the NAND will not work. So this is crucial that you get this installed with a strong solder joint. And that's what you're going to see me do here. Add some flux. I'm sticking the soldering iron in the hole to heat up the solder. Then what I'm going to do is add some fresh solder to this until the gold pad and the hole are fully filled. You don't want to fill this too much, as the SD card slot has to go over this, and the clearance is like 0.5 millimeter. So just make sure that there's enough solder that fills the hole and then it just covers the gold pad. Once you have it soldered in place, you can go ahead and clean up the flux with some isopropyl alcohol and a Q-tip, and that's what you're going to see me do here. Also, over on the left-hand side of that ground point is this little copper spot on the board. Seems to be a manufacturing defect where the board masking is missing. I know they look big in the video. They aren't. They're extremely tiny. I couldn't even see it without my microscope. It doesn't really matter. Nothing will be touching there. So if you get an NAND with similar spots, you can ignore it as well. Also, I wanted to take this time. In my original video, I didn't mention this. Before you move on from this step, please make sure that you have a strong solder joint at this ground point. Otherwise, it's going to break off and you're going to have to redo this entire job. Once you got the ground point soldered in place, you can go ahead and move up here and tin these pads for the resistors. Remember, use flux. Flux makes solder flow. Once the flux is in place, what I like to do is add a little solder to my iron, and then I just come in here and I tin these pads. Once the pads are tinned, I like to come in with my soldering iron and solder each one of these resistors to the NAND. You need to make sure you add enough solder so that the NAND makes contact with the left side of these resistors. You could potentially do this job without a microscope or I suppose some other magnifying device, but it's really difficult to look at these and make sure that they're soldered in place without one. A good soldering job will look like this with nice round balls or peaks. It doesn't have to be perfect, so if you can't get these, don't worry about it. It's mostly aesthetics. If you're having a really tough time and you're ending up with like really jagged edges or peaks or spikes or something, add more flux. That's the reason why you're getting those. Once that's done, I'm going to go ahead and start cleaning up the flux with isopropyl alcohol and a toothbrush here, and I recommend you do the same thing. Also, when you get done soldering these, I highly recommend you check them with the multimeter. Again, set it to continuity and check the right side of the resistor and the NAND board. If there is no connection at any of these resistors, a single one of them isn't connected, the NAND will not work. So it's better just to double check and make sure. Don't rely on your eyes even if you got a microscope. Just grab your multimeter. Once that's done, we're going to come down here and tin these big gold pads here. They have the grounding points that hold and ground the SD card slot to the NAND board. There are 2 of them on the top side for a total of 4. So once again, add some flux. Then add some solder to your soldering iron and come in with the hot iron and tin the pads. And I'm also going to tin these 9 pads for the SD card slot data pins that are in front, along with these 2 large square gold pads where the capacitor needs to be installed. Also, when you're tinning these pads, move with the pad, don't move against them where you can cause scraping that could damage the pad. Alright, so I mentioned it earlier in the video, probably about a minute ago. This is where I'm cleaning this section up with isopropyl alcohol and a toothbrush. And I'm doing that so I can verify that I have a good connection. On the right side of the NAND here, where I'm adding the flux, there isn't a good, there isn't enough solder, so I'm adding a little bit. And now you're going to see me do some more cleaning of these resistors using isopropyl alcohol and a toothbrush. I like using 100% isopropyl alcohol. If for some reason you can't find that, 90% and above will work just fine. So this pad that we're looking at right here, I have a little bit too much solder. If you run into this problem, just grab some solder wick and wick it off the board as you see me doing right here. And what I'm doing off camera is getting the SD card slot reader here. And now what I'm doing is putting the SD card slot here to test fit it and make sure it lines up. I like to solder the top left leg in place first just to get things started. I don't want to put a lot of solder on here to start just in case I need to shift this around. So I'm going to start with the minimal amount. You can see it's stuck when I push it, so I can move down to the next leg. Alright, a little bit of flux to get the solder flowing that's already on the pad. Bring in the hot iron and add a little more solder, and boom, there's a nice connection. Alright, so what I'm going to do is the same for the other 3 legs as well. What I noticed filming this video is it's very difficult working on a camera equipment and a microscope, which you'll see right here. I pushed the microscope out of the way. I just couldn't get to this pad with the soldering iron in my left hand and filming at the same time. There just isn't enough room to work. Alright, so we're back with the microscope and that leg's all set. I'm going to move on to the leg up here. Same as all the other legs, add some flux and add some solder. So this is the leg I recommend you avoid if you don't have a very fine tip soldering iron. The reason for that is this capacitor on the bottom here is so close to the nade that it's difficult to get in here with the soldering iron. Even with a very fine tip soldering iron, I'm flexing it slightly, which you can see in this video. If you damage this or bridge the nade to this capacitor, things won't work. So if you're able to solder the other 3 legs, you don't have to worry about this one, and I recommend just avoiding it. Alright, and once again, I'm just coming in here cleaning the flux with some IPA and a toothbrush. IPA is isopropyl alcohol. I'm just going to call it IPA for the rest of the video. Once you're done soldering the SD card slot legs in place, we're going to come down here and solder these 9 data points for the SD card slot. 2 large pads in front of the 9 pins is where a capacitor is going to go. I like to use these 2 large pads to transfer solder from the pads to the 9 data pins. It makes it easy for me to add a small amount of solder to the soldering iron and then touch the pin with it. Of course, you can do whatever works for you. Again, make sure to add some flux to these areas because flux makes solder flow. When you're soldering these 9 pins, you don't want too much solder on these pins as it could flow up under the SD card slot where you cannot see it, and it could end up bridging 2 of the pins. You also don't want to put too much solder because if you overheat this area around these pins, you're going to melt the plastic that makes up the SD card slot. So take your time and go slow. I got a little too much solder on this pin right here, and I'm wicking it away and putting it on the pads in front where I can remove it using solder wick if there's too much there. And right there I misplaced the solder and melted it high in the soldering. If you do this, just grab some solder wick and touch it where the blob is on the soldering iron and it'll suck it up. Alright, once you got those all soldered in place, I'm going to go ahead and clean this up with a toothbrush and some IPA so I can inspect the area. Again, check your connections with a multimeter. It's a lot easier to check these while you're working to verify you have a strong and good connection instead of waiting to find out once you've reassembled the console something isn't working, and then you'll have to take it all apart again. If you want to check these points with a multimeter, all you have to do is put the black lead on the metal plate that's on top of the SD card slot reader and then check all 9 pins and you should get continuity. And once you've verified those pins, let's move on and put the capacitor in place. This was undoubtedly the most difficult part of this entire video. Trying to solder this tiny capacitor while filming is just difficult. It's very, very hard. It's a small area on the board to begin with, and I had to work around a microscope and a camera. I was trying to hold 3 things at once, and honestly I needed a third arm, but that's obviously not going to happen because humans only have 2. You will see that this capacitor doesn't go on perfectly straight, although ultimately that doesn't matter as long as it has a good connection. So don't stress about it if you're having difficulty. I got a lot of comments and a lot of emails from individuals who followed my original video, and they said that this was difficult for them to do and asked if it was okay if it was a sloppy job. The truth is, you just need to make sure that it's soldered on both ends on these pads. It doesn't have to be flat, it doesn't have to be flush, as long as it's soldered in place. Also, a tip for doing this is to get one side of the capacitor soldered in place, then solder the other side. If you have to shift this capacitor around, you can heat up both pads with the soldering iron and use tweezers to move it around, which you're going to see me do in this video. Here I'm checking the capacitor with the multimeter to make sure that it has a good connection. And then I'm just going to clean this area with IPA and a toothbrush so that I can inspect it. Now I don't know if this is visible in the video or not, however I am using the microscope here to zoom into the bottom pad, and there is a crack in the solder joint, so I'm going to reflow this solder. Unfortunately, the focus for the camera is not the same for the focus for the microscope, so I couldn't film this portion of it. And like with everything else, I recommend checking this with a multimeter, and that's what you're going to see me doing here again. I'm just double checking to make sure that this has a good connection. And I have a good connection to that capacitor, so I'm going to go ahead and clean up this area with some IPA and a toothbrush. And as you can see, my capacitor isn't exactly straight, but it doesn't matter, it has a good strong connection. The last thing we have to do is solder the 3-volt wire, and it has to go from the NAND-AID to the Wii U board, and you're going to see me tin this pad, and this is the 3-volt pad. What I like to use for this is a 28 gauge enamel wire. The reason for this is the enamel can be burned off the wire easily with some flux and solder using the soldering iron. What I recommend doing is using some flux and solder to burn the enamel off the end of the wire before trying to solder this on the board. As you'll see, I already tinned this because I've removed that enamel coating and it goes in effortlessly. Now the other end of this wire needs to go over here to this leg. The leg is what is known as the Q6 transistor, which happens to be right next to the R10 component, but it is not the R10 component. Try to get the solder only on the wire and the leg of the transistor. While the gold circles, which are called vias here, apparently connect to the same trace, it's probably best not to get solder where it doesn't need to go. I recommend adding a little solder to the leg of this transistor and then grab your tweezers and bring this wire down to the leg, and it should stick enough that you can finish it off by adding some extra solder if you need it. I had a little I had too little solder in this joint, so I added some flux and added some more solder to make it stronger. And that's a lot better solder there, and we'll get this wire soldered back down. At this point, you can clean up the board using IPA and a toothbrush and some Q-tips. The entire job should be complete. I recommend checking all the soldering joints with the multimeter to make sure you have a good connection. It's easier to do this before closing the console back up and reassembling it. With that said, good luck with your repair, and I'll see you in another video.